Yeah, the psychosurgery was the thing, right? They still perform things like lobotomies where you would sever the prefrontal cortex. If somebody if their mental disorders were, too much to handle. Basically, they just didn't have drugs that could calm people down, right? And so his epilepsy had become so severe that it was debilitating. And they'd known from experiments with monkeys that you could remove the hippocampus. And see, what's happening with an epileptic seizure is to your brain, the neurons are all firing, and it's just a big ball of noise, your brain, if you were to look at it. When somebody's having a seizure, there's these waves of synchronized firing that go across the brain, right? And one thing you might want to do is try to stop the brain, the neurons from firing in a synchronized pattern. And they had found that cutting out the hippocampus was a good kind of relay station that would, if you took it out, these waves wouldn't occur anymore. They'd shown it with monkeys, and what they'd also shown with monkeys is that they could undergo learning. So, press a bar and get a pellet. Press the bar when the red light is on, you'll get electrocuted, right? Taking out the hippocampus didn't affect this. So they said, well, it doesn't affect memory, right? Because back then we didn't think about memory in these different ways, right? You had memory. So HM wakes up. He can talk. He can interact with people. His IQ is normal, but he can't remember anything more than a couple minutes ago. Right? He can't form new long-term memories, and every time his context changes, he forgets what was going on. Right? You could tell him a joke, leave the room, and come back, tell the same joke, and he'll laugh just as hard as the first time. Right? That to hide mirrors from him because as he's aging, it scares him to see himself. He doesn't understand why the reflection is so old, right? So things like that. We'll come back to him, but when we talk about short-term memory being a specialized system, you have to understand that nowadays we love to section memory into all kinds of things. It wasn't always that way. I mean, it's like I was showing you with the maps of the solar system or the models of the solar system, right? You need evidence to support your theories. If you're going to have two memory systems, you need evidence that there should be two memory systems, right? So, at the same time, computers were becoming a thing, right? And smaller, more digital computers. And the idea of RAM was becoming a thing where a part of the computer's long-term memory would get moved into temporary storage so that it could be accessed readily, right? Kind of influenced the way we think about the brain, the technology did, right? And so I already pointed out this kind of proto-notion of short-term memory that came from Broadbent's model, right? And the idea here was that I'm trying to recall these digits got played into this year, these digits got played into this year. I have to say everything. And he noticed that, people can recall 261, they think for a minute, and then they say 795, right? So they seem to be referencing some kind of a short-term store. So what Broadbent referred to this as, and I seem to have lost my mouse because this thing's stupid. Something is up with my computer today. So what Broadbent referred to these components as, and you don't need to write them down because nobody talks like this anymore. I'm just showing you. He spoke of the S system, which was kind of like a short-term store, and the P system, which would be conscious awareness. And they function together, right? Awareness references this short-term store. Now, neither one of them would be what you call short-term memory. Short-term memory is assumed to be more of a phenomenon than a memory system on its own, right? It's a result of processing components in the brain, right? That short-term memory arises from the interaction of the P system and the S system, right? Some of the stuff you remember, you're consciously aware of. Some of it's back in the store, and you can kind of shift between the two sources of information. But there's going to be limited capacity to it. You can only be aware of so much stuff. You can only maintain so much stuff, right? I already said awareness is limited to about 3 or 4 items. And the idea here would be that you could maybe hold 3 or 4 items in some kind of storage. When you combine those two together, 3 or 4 in awareness, 3 or 4 in storage, together that is short-term memory, right? 6 or 7 items. An important part of this, though, is that S system doesn't last forever, that short-term store. Anything that is not rehearsed disappears quickly. Now, I say you don't need to know the S system and the P system, but that doesn't mean that you can just let go of the concept, because this is very much still with us. This model started in 1988 and has become one of the more accepted models over the last 30-ish years of looking at the mind. This is Nelson Cowan's working memory model. Now, you don't need to know everything. We'll get more into models later, but I just want to show you this so we can see this idea of short-term memory in the present. So there's a bunch of mess here, but we're going to zoom in on this box, right? And the idea with the box is that if we imagine that this is long-term memory, right, which the box should be gigantic relative to this, right? This is just a tiny aspect of long-term memory. You would have the focus of attention, those 3 or 4 things that that are properly updated in conscious awareness, and then you have activated memory. So what's activated memory? Well, I've talked about this notion that you say words and you recognize the word because memory becomes activated, and we've talked about something like a late selection where everything activates all the memory, right? So, but the idea is that really what activated memory is neurons firing in some kind of a certain pattern, right? And then that pattern, without reinforcement, without attention, is going to fall apart really quickly, right? And so in the modern perspective, you can stay consciously aware of something, and then the rest of short-term memory is just this activation in the brain rising and falling. And what I mean by activation rising and falling is really like patterns of firing, synchronizing, and then coming apart, right? Without constant rehearsal, right? But Colin would say that we have rehearsal systems, which I'll show you about this later, but we have rehearsal systems that allow us to keep some of this activated, just kind of cycle through a portion of our conscious awareness to keep that activation going on something, right? If I'm rehearsing a phone number in my head while I'm trying to focus on something else, really what I'm doing is using a little bit of my attention to focus on something, and I'm using some of it to keep rehearsing and keep these activation patterns, keep them going, keep them together, right? Now, don't worry if you don't get all of that. The point is I'm just showing you that, I show you this old stuff, but it still conceptually is with us. So this brings us to the modal model. I introduced this last time. I thought this was the week that I asked that on the quiz, but it's actually next week. I'm telling you what question number 1 for next week's quiz is going to be, right? Question number 1 for next week's quiz is going to be what the modal model is. And for some reason, even though every time I've ever taught this class or some version of it, and I've told people this, half the people in the class still get it wrong. So perk up and pay attention. I guarantee this will be question number 1 on next week's quiz, or question number 2, somewhere in there. It'll be on there. So the modal model, right? And by modal, right? It's very cute, modal model, right? But it's actually meaningful. Mode being the 3 types of average: mean, median, mode. Mode being what's the most commonly occurring in my set of numbers, right? I have 10 numbers, and most of them are, unique, but 3 occurs, 4 times. Well, 3 would be the mode, right? Now, you can imagine. I mean, you look at a textbook, and it sounds like everything in psychology or whatever discipline you're studying, it seems so settled, and everybody has it done. No, once you get outside those textbooks and get into the literature, you see that people are fighting over everything, right? And the models that you read about are the ones that probably have the most evidence behind them and the most acceptance, but that doesn't mean they're the only game in town, right? And so, sometime in the 1960s, his name, Bennett Murdoch, came up with this term, the modal model. And it's just that if you take all of those theories, right, these are the things that are most common to them, right? They're the most commonly occurring components across all theories. And I mean, it's a good idea. It's an influential idea. And in fact, when you read any introductory textbook on psychology to this day, when you read the chapter on memory or the chapter on cognition, they present memory via the modal model, right? It's in a set of assumptions that regards the distinction between short-term memory and long-term memory. I mean, part of the modal model is the idea that there is a short-term memory and a long-term memory, and they are distinct, right? There's also other things that we assume that separate them, right? Because if you're going to have theories with more than one component, you need evidence that you should have more than one component. As I said in the first week, or maybe it was the second week, we function on the basis of parsimony, right? The simplest solution wins. And if you propose there's going to be 2 factors, but long-term memory and short-term memory, but you don't have evidence, then one factor is the way better solution, right? So these are the assumed differences that people typically accept. First off, and most obviously, is that short-term memory is limited capacity. As I said, about 7 items plus or minus 2. Or if you want to be really strict, focus of attention, 3, whatever. At some point, there's a system that holds a limited amount of information. Right? Doesn't matter which theory, right? This is the modal model. The other side to it is this notion that long-term memory is unlimited, functionally unlimited. We have no evidence that permanent forgetting ever occurs. For instance, I'll say, you get urban legends about this. People say, Einstein learned so much he forgot how to tie his shoes. That never happened, right? That's a urban legend. Or you see it in TV shows, like the dumb character learns a whole bunch of information and then can't do basic things anymore, or can't remember basic things. That doesn't happen. And in the 80s, there was this really cool study that was done with people who had taken Spanish in high school, and then they would show them a word. I don't know. Dog, right? You'd see it in English, and you'd have to produce the Spanish word, which I shouldn't have gone with that example because I can't remember how to say dog in Spanish. But that's not the important point.
Para.
What's that?
Para.
All right, great. So people that just got done with high school remember that. People are 10 years out, last 20 years out, last 50 years out, whatever, right? And we're talking about people who generally don't use it, right? They learned it and then went away. But you change the type of test. You give them 2 words in Spanish, and you say, pick the one that means dog, right? You see this dip in learning, but then, throughout the rest of people's life, it's basically consistent. They can recognize the word just fine, right? Memory's still in there. It's just not being accessed properly, right? So Yeah, potentially everything that you ever learn is in long-term memory. You just don't cue it right. We'll get into that later. That an important component of long-term memory is cueing memory. It's providing the correct set of circumstances that kind of match where you learned it, right? So a recognition test where I say, here's two words, which one is dog, which one means dog, right? I'm facilitating the retrieval by giving you the correct answer. You just need to kind of know that this one's not correct. Now, the other critical aspect of the modem model is the idea that information decays in short-term memory, right? Unless you're rehearsing it. And I'll come back to this, but the classic one that you see in textbooks over and over, which makes me grind my teeth, because I'm going to tell you right now, it's not accurate, but it's repeated over and over again because it's easy to understand. And hopefully, by the end of next week, you will understand why this is not accurate and why I always want people to tear that page out of textbooks. Supposedly, the information in short-term memory is going to decay within 18 seconds if you don't rehearse it. It's a good rule of thumb. It's just not exactly true, right? It's not as true as people often make it out to be. Heuristically, things last for about 18 seconds in short-term memory, though. Second, get this. I'm cutting out. Does everybody else, are other people hearing me cut out?
No.
All right. All right. All right. Well, some people are getting me cutting in and out. Hopefully, though, hopefully you got most of it. What I'll say is that mostly I was just going over anecdotes that I'm going to repeat anyway. So hopefully you'll catch them the second time around. Just if you feel like you missed something, just just give me the message, and I'll just type it out if it's something that seems like particularly important. Anyway, so now the idea with long-term memory is if it lasts forever, right? Why do we forget? If it's always there, why do we forget? Well, the idea is that hold on, let me make sure. All right. Well, some people are getting some degree of cutting in and out, but hopefully it's not too bad. I don't know. The idea is that retrieval is competitive. There's a lot of noise there. You've learned a lot of things that are kind of similar to other things that you've learned, and you've learned lots of things in the same environment, right? And all of those things can add up to a situation where when I ask you to recall something, there's just simply too much noise. Now, we're going to slowly get into that, but to understand, memories interfere with one another. They compete for retrieval. You can think about it that way. Other aspects of this model is that information is only going to become part of long-term memory if it was first in short-term memory. That makes enough sense, although some people have challenged it a little bit. And that information is, when it's retrieved from long-term memory, it's copied into short-term memory. This is one that I can say without fail or without any reservations, it's not true. But I can explain why it's not true real quick. But it came from the idea that, the computer idea, right? You got your long-term memory, and then some of it gets pulled into RAM to be used really quickly, right? So that was just kind of where people were starting from. Now, humans are not computers. The computer model was a great starting point, but we have the brain could be thought of as a computer, but it's an analog computer, not a digital computer, right? And what I mean by that is, if you think of those old computers where you had plugs, right? And you would program it by plugging things in, right? The hardware and the software, the program and the hardware were implemented together, right? And that's the way to think about the brain, right? I've already said, an active memory is really neurons firing in a certain pattern, right? What I mean by analog, right? It's all the right connections are made together at the same time. And so, having said that, the reason that long-term memory isn't just copied into short-term memory, or the reason I'm confident that that statement is not true, is that memories change over time. They become less accurate, right? You see yourself in a more positive light over time, right? Or, your stories diverge from other people's, different characteristics, because every time you recall something, you rehearse it in a certain way, right? And over time, you begin to warp the long-term memory, right? Or if you want to think about it mechanistically, you got these neurons and they're communicating with each other with different strengths. And every time you remember something, maybe you change the strengths of the patterns. And so the memory starts to become fundamentally different, right? It activates in a different way every time. So because there's ample evidence that long-term memory becomes less accurate, I'm pretty confident in saying that it's not just a copy into short-term memory when you remember something, because it seems to be that we actively change our memory over time. Every time you remember something, you wind up screwing it up. Now, let's do another free recall. This one will not be a DRM list, so there's no trick to it. So everybody get a piece of paper. I need to change where this fan is at. And I also realized that I plugged in my cell phone, but that's my clock. So I'm going to go grab that. Well, you grab a piece of paper. All right, yeah, because I do want to keep this well timed. There is a point in this lecture where I have to make the judgment call of whether we push forward or if we end early, just because of, well, I don't want to leave off at an awkward point. All right, so if you remember free recall, you see the words, they're going to come up one at a time. When the question marks come up, write them down. All right? Everybody remember to do that? Let's do it. Ready, set, go. Get ready. 3, 2, 1. Home, mind, room, limb, flag, palm, beef, park, brat, slug, type, game. Okay, so these were the words. To score yourself there. I want to stop the share for a second, but give yourself some points. Let's bring up let me get the poll here. Right, because this is why I wanted to take it off the share. All right. So I'm going to launch a poll. It's just going to ask you if you remembered 4 of the words. Just give me a yes or no answer. Okay. Some people didn't vote, but that's fine. Let me bring this back up. All right, so we look at the poll here. Right, home, mind, room, blah, blah, blah. So home was the first word. 93% of people recalled it. Home was in the middle. Boy, I love this, man. Oh, you know what? I love having these polls. Look at this. You know how annoying it is to do this in class and be like, oh, did you kind of remember that? And some people raise their hand. Some people just stare at you because they're like, oh, you're an asshole. Stop talking and let me go home. But anyway, here I can, well, I guess 4 people are still doing that. But anyway, or 6, excuse me, 6 of you don't like that. All right. Anyway, 25% said yes for Palm, 55% said yes for Park. Stop doing this to me. And 80% said yes for game. So, sorry. So, the early word, remembered well. Words in the middle, word at the end, remembered well. Right? This is the nature of free recall. Right? This is how memory works. So this would be an example of these kind of data. If we could just put it all together over enough people, right, we'd have the probability that the word is recalled here from 0 to 100%. And the order in which the word was presented. So the first word, that would be home, and then the last word, game, would be there, right? And home and park would be somewhere in here, right? And this is the course that memory follows, right? So these are known as serial position effects, and they were very important to the development of the modal model. As I said, Bennett Murdoch was the person who came up with the term, and I believe he's also the person who first kind of formalized these serial position effects, if I'm correct. So the first effect we have here is the primacy effect. Now, I will speak slowly because I think I've asked you to write this stuff down, and I mean, I want you to know what a primacy effect is. I want you to always remember what that is, because it's real, right? I can say a stupid anecdote while you're writing, but I'll say, first of all, let me just read the definition, right? It says that the first few items on the list are better remembered than the middle items. So let's start an example here. If you're in a public debate, right? The presidential debates are coming up, although they're not really debates. They're just people yelling at each other and trying not to answer the question. But let's pretend it was a real debate, right? You might have somebody state their case first, and then another person states their case second. Or like, in a legal setting, right? The defense always gets to go last, right? Prosecution goes first, I believe. I've never been to court, so I forget these things. High school was a long time ago. Right, so that's the primacy effect. And if you were in a debate, there are cases, I'll go over the different cases, but there are cases where it might be good to go first because people are going to remember you best, right? Now, it's traditionally assumed that the reason that we get this primacy effect is because people have more time to rehearse that information in short-term memory, right? It stays in short-term memory longer, even if you're not consciously doing it. You're saying it over and over. It gets into long-term memory with a higher probability, right? And that's also kind of a traditional assumption, is that rehearsal of information in short-term memory is what is critical to transfer into long-term memory. Although, remember that one for only a little while, because I'm going to knock that one down too, eventually. But anyway, it's not just that there's more time, but those items are also distinct in short-term memory, right? They can get rehearsed. You're not spreading your rehearsal or your whatever we want to call rehearsal. It doesn't have to be you saying it in your head, just some kind of way of remembering it. It's more, these first items are more distinct, whereas as you bring in these middle items, short-term memories getting crowded and noisy, and stuff is going to be passed through with a lower probability. So evidence. evidence for this, here, let me, oh, come on, you stupid thing. All right, sorry, we had a question, so let me, well, I'll come to that. Don't let me, all right, so I had a question about if you're going for an interview, should you choose the first or last slots? Don't let me finish with this until or don't let me finish with this component without answering that question, because it is a very good question. It's very important. But there are aspects to it that I wanted to bring up. So yeah, if I get past the part where, if we get to the modality effect and I have not explained this, then stop me and remind me. All right, but anyway, some evidence for this, like, rehearsal-based account of the primacy effect is that if I speed up the presentation of the words, the effect gets smaller. So if I'm presenting words at 2 per second, or no, excuse me, 1 word every 2 seconds, this effect might be way up here. Whereas if I'm presenting, let's say, 2 words a second or 4 words a second, the primacy effect is going to disappear at 4 words a second. So we're talking about a quarter second per word. You don't get a primacy effect at all, right? Which suggests that, yeah, they just didn't get as much rehearsal as it normally does. Right, so the early items are received last rehearsal and can't be transferred into long-term memory. Okay, so, yeah, also, if before the trial starts, if I give you a 6-digit number, you know, or let's just say I make you count, well, yeah, so 6, 4, 7, 3, 2, 1 or something, right? And you have to say 6, 4, 7, 3, 2, 1, 6, 4, 7, 3, 2, 1. You have to either say it out loud or just repeat it in your head and be able to say 6, 4, 7, 3, 2, 1 when the trial's over. If you're doing that, the primacy effect is going to go away, right? So again, if short-term memory is kind of taken up, you can't rehearse this information and it can't transfer into long-term memory. Okay, so we don't really have a name for this. There's no middle effect, but you know, the important thing to remember is that the middle items are just, they're never really recalled that well. Things in the middle are easily forgotten. Middle children are always forgotten, right? They're always complaining that they're the forgotten one, right? These are the middle children. I've seen this effect with just even like a 3-item list. Literally, 3 items are the easiest list to remember, but you still see that little dip in the middle one. People don't remember it that well. And from this account, it's because the items receive less rehearsal, don't transfer to long-term memory. I don't know. Don't worry about why too much, other than knowing that that's true, right? Middle stuff is. You don't remember the middle of the school year all that well, right? You remember the beginning really well, and you remember the end really well, but that middle part's kind of a mess. Now, the other one is the recency effect, right? The last few items on the list are better remembered than the middle items. Often they're better remembered than the first item. So we go back to the debate example, or we go back to the example of a job interview, right? The question might be, no, I'm going to tell you, don't go in the middle, right? The middle is the forgotten part, right? So we can agree on that, right? But the question would be, is it better to go first or go last? Well, let's go over some of the properties of this recency effect, right? First thing, does anybody want to venture a guess as to why we get a recency effect? Why those last items on the list are remembered so well?
Is it because you're better able to rehearse it?
Hold on. I had someone. Where's the hand raised? Kelly, was it? Can you open up your mic and say what you're? Yeah.
I was thinking it was because of your memory of the spoken word. For example, when we just did that list of 12, I remembered the last item because I remembered you saying it. I could actually.
It was in short-term memory, right? You're just offloading short-term memory, right? That's basically the classic example, right, or the classic reason. And there's been good evidence for this. So it's traditionally just explained as people dumping information out of short-term memory, right? Sorry, I'm trying to go slow because there's probably people that are writing this down, which I'm completely fine with. Sometimes I'm like, don't take notes. On this one, I'm like, yeah, you want to take notes is probably a good thing to write down. It's a good thing to know.
I was thinking about the different reason for the recency effect. The masking. If you have simultaneously without enough delay between two words, then those two interfere each other. And at the end of the words, there's no beyond additional words, so there's nothing to be interfered.
I would say that Ian Neath, the guy who wrote the chapter that you read, made a mathematical model that showed that's a very probable explanation. So yeah. But I'm not going to get into it that much, right? We're still in the basics. But yes, it's what we would call retroactive interference. We'll have that definition come up eventually. But the best evidence for this time-based forgetting, like information just being dropped out of short-term memory, is what we call negative recency. So negative recency occurs with something that we might call final free recall. Right? So in final free recall, let's say the experiment was 10 lists long, right? You only did one list, but you do an experiment where you do, 10 lists, you see the list, you recall it. You see list 2, you recall list 2. You see list 3, giving you the middle finger backwards. List 4, 5, and on down the line, right? And so, yeah, you do all 10 lists, and you're about to leave the study, and I say, hold up, come back. All right, what I want you to do is all the words that you saw in all those lists, try to remember as many as you possibly can, right? And negative recency is that in that delay, the recency words, those words that you remembered so well, are the ones that you remember the worst, right? The recency effect goes away. The primacy effect, you'll continue to remember those words for a long time, right? The primacy words will make it onto the negative recency or the final free recall list. Negative recency is that those recency words that were really fresh in mind when you started, they just go away. It's as if you never rehearsed them, you never really tried to get them into long-term memory. It's just they were floating in short-term memory, and bam, you wrote them down and let it go, right? Right, like I said, they were dumped from short-term memory, so they never transferred. So the question about in debates or job interviews, should you go first or should you go last? Well, there's two reasons that you might choose to go first, right? And I'm sure what you've heard is go first because you kind of create an anchor point for everybody else, right? You create the point of comparison, and there's good evidence for this, particularly in social psychology, that primacy effect does kind of set the tone. I don't think I'm going to come back to that because this is not a thinking class, but more of a memory class. I mean a class on the concept of thinking. But yes, it does kind of set an anchor point. But let's think about this in terms of, you get the most information out. Who's going to remember you best? Are they going to remember the things about you best? Well, the answer in a debate or a job interview, whether you go first or last, is you really need to know when the judgment is going to be made. If they're going to, right after the final person or the final speaker, they're going to go make a decision, then go last. Because they're going to remember you best. They're going to remember the things you said best. They're going to remember your attributes best, right? But if there's going to be a delay, if they're like, yeah, we'll interview everybody, but we'll get back to it. We'll make a decision, next week. That's what's on the calendar. Or, you're in a debate, and I don't know, there's an intermission. You go have punch and come back. Then go first, right? Because negative recency. The final person gets forgotten, right? Whereas the first person sticks around in mind, right? So if it's right away, you want to go last. The judgment is right away. If the judgment is first, or if the judgment is later on, then you want to go first, right? Because at least in terms of sticking around in their memory, that's how it's going to work, right? So I think I brought this up a little bit, like reading some economy type studies where they were looking into this, just trying to figure out what, like behavioral economics, trying to figure out how people judge experiences, right? So they have them read vignettes of a vacation. And at some point, something would go really wrong in the vacation, right? And then, so generally beginning or end, right, of this vignette. And if they asked them to kind of make judgments about whether it was a good vacation or not, people would say, yeah, it was good if good stuff happened at the end and bad stuff happened at the beginning. But if, you made them go away for a day and come back and ask them, if bad stuff happened at the end, they would kind of forget about it. But if bad stuff happened in the beginning, they would say, oh, yeah, that was a terrible vacation, right? So your memories do wind up getting colored by the order in which these things happen, but the effects are present over different time periods. Sorry, I'm kind of going on, but I just think it's an interesting topic. Now, modality effect. This is important because it tells us something about the nature of short-term memory. So let's say you're doing the free recall test, right? And let's say I have two groups. One of them sees words on the computer screen, but there's no voice. And another group hears it over headphones. Now, Kelly, you already brought up that, those last words I said were kind of ringing in your ears, right? And that is essentially the modality effect. If I play it over headphones, you get a larger recency effect than if I present the words visually, right? There's not much more to it than that. Sorry, I'm going to go back to that. I just wanted to see what I said next.
Should we take this as the auditory system takes more portion in our brain than visual does?
I'm going to come around to that real quick. I wouldn't say it's quite that. I'd say in this instance, it's that essentially what it's indicating is that there is a component of short-term memory that is maintaining, I say verbal here, but I think phonological, don't worry about it really, right? Well, yeah, maybe. There's a part of short-term memory that's maintaining, I say verbal, but let's say phonological information, sound, right? Sound maps onto words really well, whereas like the visual representation, you kind of translate it in your head, right? And we'll get into the components of short-term memory that are considered to be responsible for that, but we'll get into that later. We got to worry more about long-term memory. But for now, what I want to say on that topic is, the most famous model of working memory is Baddeley's working memory model. Sorry that this is all, I pulled it off Google a few minutes ago, so sorry it's looking like this. But essentially the idea here is that you have the central executive, which nobody really knew what this was when I was an undergrad. It's become more clear over the last 20 years. So we're talking about attention control, right? But badly divides short-term memory into two broad components. You have a short-term memory that's specific to verbal information and one that's specific to visual spatial information, kind of what and where, right? And so that advantage that you get in the modality effect is essentially this can be stored in here really easily. This, which was visual, not really going to be there. And visual, you can't really rehearse the way a word looked, right? It doesn't really work that way. So you don't get good rehearsal advantage when you see something visual.
Does that have...
Oh, sorry. Yeah, what's up?
Does that have any exception for... I'm trying to remember where I read this, but like there was a study shown that like if there were instructions for an assignment and it was put in like a really weird font so that the learner had to work harder to read it, that they remembered more of it.
Sorry, what were you going to say?
I was just wondering if that has any relation to that, or if that...
I think that most people would say that it's probably one of two things. Let me look up the term to make sure I use the right one. But one of them could be... sorry. Yeah, okay. One of it could be that you have to pay more attention to it. It's harder to read, so you focus in on it more, right? As I said, word reading is fairly automatic, which also, you think, well, I read words that I don't remember all the time. Yeah, it's because it's automatic, right? And I can prove that to you because quite often you're reading and you get to the bottom of the page and you're like, oh, what the heck was I reading, right? And so you have to go back up to the top and read again. Your eyes are processing it, your brain's processing it, but you're not applying attention to it, right? So one thing is that a weird font could perk you up, right? Snap you into place. The other is that it could potentially be what we call a von Restorff effect, which it's isolated or unusual, right? And we remember those kinds of things, If we had, I talk about, you don't remember these words in the middle, but, and sorry to be crass on video, but, if I had put fuck right here, you would remember that 100%, right? That would be a von Restorff effect. There are lots of things there are lots of mechanisms that could lead somebody to have better memory with something like that. Right. Let's talk about why we forget from short-term memory. The classic debate is decay versus interference, right? So, although I was talking about things quite a bit in terms of, forgetting the middle of the list because it's not really rehearsed, and you forget the end of the list because, it just kind of decayed from short-term memory, never tried to transfer it over. I mean, Ted's already offered a interference-based account of forgetting. So, I can't even make it through an undergraduate class without us getting into that potential problem. Now, you might be wondering what the hell interference is, and that's what we'll get into, right? Why do we forget information so quickly? Is it because short-term memory just decays? Or is it because memories interfere with each other? Now, decay is the classic explanation. It feels like it, right? I mean, if I tell you a phone number and I tell you to, all right, punch it into your phone, right? You're going to be saying it to yourself over and over, and then you punch it in, and then you just feel that memory just kind of fizzle out, right? It feels like short-term memory decays. And it's also important because, as I said before, when we talk about the concept of parsimony, theories, if we're going to say there's a long-term memory and a short-term memory, the properties ought to be different, right? And so one of the major differences that we assume is that forgetting occurs for different reasons. So, what do I mean by memory decay? I just mean that memories corrode with the simple passage of time, right? Oops. So, yeah, you're rehearsing something, and then I distract you, and 18 seconds later, you can't remember it, right? 15 seconds later, you remembered maybe, 30%. 9 seconds later, you remembered probably half of what I had told you, right? The memory just falls apart and goes away. Now, this makes enough sense, but Melton in the 1930s had already stumbled onto the fact that there are problems. What he pointed out was that iron rusts over time as well. Just like memories corrode over time, iron rusts over time. Time isn't a causal factor, though. Time doesn't cause iron to rust. Oxidation causes iron to rust, right? And so, from his perspective of Neith, the guy who did the writing today, and a lot of other people, time-based memory decay is not, it's a phenomenon, it's something you experience, but it's not a causal mechanism, right? Why do memories go away? They decay. Well, a lot of people think that's just not a good enough answer, right? Much like, why does iron rust? Well, it was sitting out, right? It's been out there for, 5 years in the yard. Yeah, it's been 5 years, but there's been a lot of oxidation that's occurred. So I'm not going to go over this too much because I've already said it, but if you remember, what I just said a minute ago is that it's about parsimony, right? Decay is supposed to be something that's specific to short-term memory, right? It's something that makes it distinct, makes it different. So if short-term memory and long-term memory don't actually have different properties, then we might just be back to talking memory, right? Now, the other side of the coin, and the one that's harder to understand because there's no memory decay. I don't always know how to explain it, but I think most people can just say, yeah, I kind of get what you're saying. I was thinking about this phone number, and then I stopped paying attention to it, and I kind of felt the memory fizzle out, right? But cognitive psychology, memory psychology in specific are not, sciences of what does it feel like. They're sciences of what lies underneath your conscious experience. Right? I hope by now you appreciate there's a lot going on unconsciously. So with memory interference, right, the idea is that irrelevant memories are going to inhibit your ability to recall the memory that you want. They're getting in the way, right? The memory cue is not specific enough, let's say, but the idea here then is that memories don't decay, they become harder to retrieve. I'll let people have a couple seconds to write that down because I'm just going to get through these types of interference and then we'll probably pause for the quiz. Because this actually is a really good point to leave off, just kind of review it again on Tuesday. But there's two types of memory interference. One is what we call retroactive interference.
Hey.
Yeah, what's up?
Can you go back to the last slide?
Yeah, no problem.
Thank you. I'm sorry, I just need it for
No, I appreciate when people do that. It lets me know, right? When I'm in class, I can watch people's pencils and say, hey, it's time to pause. Here, it's so hard. I can only see sections of you. So I appreciate it when people give me feedback on these things.
It's all good. I appreciate you going back. I just needed the last part. I think I had it now.
All right, you're good. All right, so the two types of memory. One is called retroactive interference. And that's when new information inhibits your ability to remember old information. When we were talking about the reasons that people forget words in the middle of the list, Ted chimed in and offered a retroactive interference account of forgetting. He's saying that basically the newer items on the list are just kind of getting in the way of those middle items. They're blocking your ability to retrieve them. Right? They're creating interference. And he's, as I said, Ian Neath would agree with him, the guy that we're reading the book for. So, you're in good company. But to think about retroactive interference in a long-term memory, let's stop thinking about short-term memory for a minute, because these interference things are well established in long-term memory, right? So one example of retroactive interference might be, in high school, I remember every year my locker combination would change, right? Or maybe junior high, I don't know. Whenever I had lockers, I think I had the same locker throughout high school. Anyway, but you often change locks, I don't know, gym lock or whatever, right? You get that old locker combination, and then you get a new one, right? And within a few days, that old locker combination is gone, and you rarely ever remember it again. Or you get a new phone number, even better, right? For a few days, you're trying to remember what your new phone number is, because people ask you, and you're like, I don't call myself, right? But so it takes you a few days, and then that old phone number is just gone. You don't really remember it anymore. That old locker combination. It's basically been replaced in the long-term memory, that kind of slot where things go, right? So now the old one is kind of blocking out the new one. Now, that doesn't mean it's gone completely, because we have something that's called proactive interference. And this is the more common problem that people face, which is old information inhibiting your ability to remember new information. So, there have been cases where middle of the school year, I'm trying to dial in my locker combination, and it doesn't work, and I try to dial it in again, it doesn't work. Or sometimes you do this with a password, right? You try to do it, it doesn't work. I'm like, what the hell's going on? And then you realize, oh, I'm putting the old one in, right? I'm trying to dial my old locker combination. I'm putting my old password in. I just was on the phone and somebody asked me my phone number, and I, like an idiot, just gave them a phone number I had 10 years ago, right? But things aren't always gone. Sometimes that old information comes charging back, and it blocks out the ability to pull in the correct memory. Or, even more common, you have so many old memories, right, impinging that you don't really retrieve anything. It's just this noise, right? Which is why more often than not, we just sit there and we're like, I can't remember. Because you just get so much information coming at you. And I will show you this in amnesia. There are actually amnesics that can't remember, not because they don't create memories, but because every time they try to retrieve memory, just this ball of noise comes at them, and there's just nothing distinct to retrieve. That's proactive interference. Or another way of thinking about proactive interference, the classic example would be, let's say you come to school and you park, or you go to the store, and you always have an area of the parking lot where you park, right? You go to the store and you do your thing, you come back and you're in your car. It's automatic at this point. But then one day, your whole area is filled in, right? So you got to go park over there. So you come back to you go to buy your stuff, or you go to your class, and you come back to get your car, and you're looking around and you're like, where the hell is my car, right? Because what you retrieved on your walk back was your usual route, right? You had forgotten that your car was actually parked all the way over there, so you kind of retrace your steps, get the correct memory. That would be another example of proactive interference. Old learning preventing new learning from coming to the top. But notice, I've only given these examples in terms of long-term memory. Okay. Right, Brown, Peterson, yeah, whatever. It's time to get to the quiz. Let me stop sharing. So remember, if you have any issues, today is my office hour day, so you know, after class, like I think I've set it to 3:45. Oh yeah, the reason I bring that up is that you know, quite often when I'm doing office hours, I'll just kind of set my computer to the side, and so if my camera's off or whatever, you come in, just yell, my sound will be on, just be like, hey, and I'll come over. But yeah, or I might be working on a different screen or something, so just yell if you come in, because I might, even if you see me, I might not be looking at the Zoom.